Okay, I'm running another experiment to do with LMD waves and displacement currents. Last night I created a new tunable matching system, or basically an inductive, it's technically LC, but using inductors for a high impedance, and this happens to give a very high peak-to-peak voltage, so it's a very high Q system. It's end-feeding a LED string, and if you've seen previous videos on this, so I've got two 1N60P germanium diodes, one push, one pull sort of thing, to rectify to DC. This is very interesting, right? And it's running the LED string. Now, I will show more here, but interestingly enough, at the end of the string, it terminates here. I theorize or hypothesize that there is a displacement current traveling along, which continues. And then over here, you can see my Rectenna system is also operating. Now, the ground side of the system is sitting on this old oscilloscope, so it's got a path to ground. So the RF is coming in, the displacement current hits this is magnetically tuned, and it has a path to ground. But it's not a one-way thing. It's oscillating, so it has electric field coming in, out sort of thing, alternating. So this also is radiating. I'll show that soon. So back to the LED string. First of all, what I'll demonstrate, and I will show you, it's also getting out well on the SDRs. I'm just going to find my RF field strength meter, forgive me. This is magnetically tunable, so I hope that I've got it tuned. Hope I didn't knock the magnet. Certainly may have knocked the magnet. Stand by. Okay, yeah, sorry about that. The magnet, if it moves a little bit, it can detune very rapidly. So, what you can see, this is a 100 microamp meter. It's not very clear, but you can see there's a fair whack of energy coming off the side of this LED string. I'll just move along further. And it's hotter at the end, voltage being higher, of course. Now, I do suspect, let me explain this, obviously with the rectification going on, when there's a positive pulse, theoretically, from the AC signal, imagine the LED string has two wires. So a positive pulse will travel along, let's say, wire A. Following that, a negative pulse will track along wire B. Now, and then of course, positive on A and then negative on B. But when we consider, let's say, the positive traveling this way on A, when after that we have the negative traveling this way on B, that is equivalent to a positive traveling the other way on B. So theoretically, we do have what would be the equivalent of a conventional current running one way followed by the other way, then one way followed by the other way. So this should theoretically be creating the alternating magnetic fields for a TEM wave. Yet I also heavily suspect that it's also creating an LMD type wave displacement current, which, as you can see, is running the Rectenna system. So, now what I want to demonstrate here is, of course, this is, like I mentioned before, it's allowing a path, but it's also tuned to resonance. So this is doing a push-pull with electric fields. Now, unfortunately, I've knocked my magnet, but even so, what you will see is that this is radiating. Stand by, I'll retune this. Okay, I've just retuned the magnetic tuning so that this little system is now resonant too. And you can see that this Rectenna system is radiating, interestingly enough. And then back to the end of the LED string, and tracking along. Now the radio does have a short ground wire that goes through the wall to an independent ground rod, And now we'll have a look on the SDRs. Okay, so firstly I'll pull up a local SDR down in Croydon. Let's hope that these are online. I'll try to get a good focus once I've got this functioning. Bear with me. You know, certainly not a pro YouTuber. Let me see. Oops, wrong tune. Hang on. 7191. Okay. So it's making it locally into Croydon. Now I'll just jump out of there now. And I'll go into VK5. Let's see, I'll jump across and choose an SDR in VK5. Bear with me, I'll clear this up as soon as I get that started. There you go, it's coming up nice. Bit up and down. Oh yeah, pretty solid there. Oh, look at that. So that's very interesting indeed. Yep, the nice new magnetic tuner, end-fed LED string in a push-pull configuration, and driving the Rectenna system at a distance via a longitudinal magneto dielectric wave or displacement currents. 7.3.